question number 10 here, right, says the following. It says here, the number of molecules, let's see, let's read again. The number of molecules of a certain drug in the bloodstream a certain number of hours after it has been taken is represented by this equation. So this equation basically gives us the number of molecules of a certain medicine, right? After a certain number of hours. Now you have to remember this represents a cubic graph. It literally represents a cubic graph. So logically speaking, we would be expecting a graph that looks something like this, something like that. You know, in the sense that the molecules, they like go down, up, and then they eventually just go down indefinitely. But then it says here, determine the number of molecules of the drug in the bloodstream 3 hours after the drug was taken. So before we answer these kinds of questions, the one thing you want to understand here is that these kinds of questions, you need to know exactly what your equation gets you. So fortunately, this equation is a bit straightforward, right? If you give it time, it's going to give you the number of molecules in the bloodstream. That makes sense, right?
Yes. So I am putting the 3 hours in the T.
Yes. Yes, because this they're asking for the number of molecules, right? Number of molecules in the bloodstream 3 hours after the drug was taken. So this equation gives you the number of molecules if you give it time. So where T is, we're just gonna give it the number 3. And then after that, we're just gonna work it out. So M here, we're gonna put a 3 there, 3 there, 3 there, and then 3 there. So in this situation now, 3 cubed is 20. Calculator.
It's 216.
216.
Yeah.
What a wow. What a wow. Oh, I think the 72 is what's causing that. 216, right? 216.
Yes.
Yeah. So it then says here, what's the next question? The next question says the following. Determine the rate at which the number of molecules of the drug in the bloodstream is changing at exactly 2 hours after the drug was taken. So this is where your theory of words comes into play. When they say determine the rate at which the number of molecules in the bloodstream is changing. So you see, keywords here, rate of change. Now let's go deeper into this. Whenever you hear the words rate of change, what you need to think of is first derivative. First derivative. So that's like super important, right? That let's see. Yeah, so that's important, right? Rate of change is linked to what is this? To the first derivative. Because if you're gonna get the rate of change of something, you have to use the first derivative. Because the rate of change equation is things like gradient. So it's the same idea here. If you're gonna work out the rate at which the number of molecules is changing exactly 2 hours after the drug was taken, you have to use your first derivative. So your equation of M, we have to differentiate it, right? So I just want to put T where the 3 is, and then we'll differentiate it. So let me just remove this, and this. So I just want to put T here. So this is our original equation. So we need to differentiate it. So the first derivative of this equation is going to look like this: negative 3t squared, positive 6t plus 72. Do you see it?
Yes.
Yeah. So with this being said, we need to put a 3 where t is.
Isn't it
then it's going to be no, a 2, yes, because they said exactly 2 hours. Yes, thank you.
Mhm.
Exactly
You're
2
welcome.
hours. Perfect. So if you put a 2 here, we can now then just put all that in the calculator. It's gonna give us -3 times the 2 squared plus 6 times the 2 plus 72. That's an answer of,
Yeah, I
so,
get 72.
yeah. So that's gonna be your answer. You see. So you can see you don't have to worry too much. You can then just say you have 72 molecules per hour. If you just left it as 72, that's still fine. Still 100% A-okay, because you get your marks for the derivative, you get a mark for subbing incorrectly, you get a mark for the final answer. This is just extra information, just to be fancy. 10.3 says, how many hours after taking the drug will the rate at which the number of molecules of the drug in the bloodstream be changing be a maximum? So again, you see they're talking about rate of change. You see,
Yes. But
rate.
now I think the trick is they're asking the maximum.
Yes. So when they're speaking of rate of change and they speak of the maximum, what do we do with the rate of change equation?
Don't you make it the greater than sign?
With max, so remember they're asking where is the rate of change equation a maximum. So anytime they're asking about where the first derivative, remember the rate of change equation, we said it is the
First derivative.
Yeah, so if they're asking where is the first derivative a maximum, all you do is you take that first derivative and you make it equal to 0. It's just like getting the turning point. Remember, the turning point of a graph is the point where the graph has its maximum or its minimum value. So in a situation like this one, we just have to take our first derivative, we have to make it equal to 0. This is things that are repeatable for questions like these.
Yeah.
If you just hear rate of change and you hear maximum or minimum, you take your rate of change equation, you make it equal to 0, and then you solve for whatever variable they're asking. You see, they're asking for the number of hours. That's why here differentiating it and making it equal to 0, you're seeing that you're working out a value of t here. And because this is a quadratic equation, you can just work it out using the quadratic formula. You see?
And then Levi, would it be the same as our minimum as well?
Yeah. If they ask for the minimum as well, you do the exact same thing.
Okay.
Yeah, because here we're going to get two answers probably. One of them is for the minimum, one of them is for the maximum. So we'll have to choose wisely.
Yeah. So in a way, it's as if this is algebra, but in a word sum form.
Yes, it's all algebra, one way or the other.
Okay.
Even in paper 2, because remember, solving equations is just algebra.
Yeah.
So let's put the b here, -6. B here is 6 squared. A is -3. C is 72. And then A is -3. Now let's put everything in the calculator. So putting everything in the calculator, let's see what we get.
So the one, I get an error. Hold on. I think I did something wrong. Do you get an error?
The first one I'm getting -4. If you're gonna get an error, just double check what you put in the calculator.
Okay, then I get a 6.
And the other one?
A -4. I forgot the -3 by the 4.
True. So in a situation like this, what you do is you have to pick which one of these numbers is the correct one. So to do that, you have to think to yourself, the easiest way to do it is to just know what your cubic graph looks like. So remember we said this cubic graph starts by going down, it goes up and then down again because the value or because the coefficient of t cubed is a negative, you see.
Yes.
So as long as you know that, what you already know is that the turning point that comes first is the minimum. The one that comes afterwards is the maximum. So in our case, obviously -4 is gonna come first. And then later on, you're gonna get a +6 somewhere. So the +6 is the one that has the maximum. You see?
Yes.
Yeah. So that's how you choose your answers. You see, you're gonna say here, therefore. No. Hold on. This question is. Let's actually not. No. Wait. There's something wrong with this question. No, not something wrong. There's something wrong with what we did. But if you read again, it says, how many hours will it take the rate of change of the molecules of the drug in the bloodstream changing be a maximum? Okay, wait, hold on. I think there's